Hi everybody, I'm going to go over the projectile motion and vectors quiz. I've already have the answers written here so you can look at them or you can listen to my explanations. Fast forward to the parts that are relevant to you. If you're doing a retake, pay close attention to these so you can do better on the retake, and you can always ask questions before you do the retake. Alright, number one, factors that affect time in the air when you fire something horizontally. Okay, so it's going to be height of the table. The higher it is, the further you're going to go. It's also going to be acceleration due to gravity. That's what's pulling it down. If it's a low acceleration due to gravity, like on the moon, you're not going to fall as fast. A lot of you answered launch speed. Launch speed is horizontal. Horizontal does not affect vertical. We did a whole lab based on that and a demonstration. Remember, I fired the dart and dropped one simultaneously. They hit at the same time. So, it's an easy mistake to make. I was a little disappointed no one answered cats, but, maybe next time. Okay, this is the one we had the most problem with, and it was worth 3 points. I gave you a point if you said something that made sense, but I've written what the outline is. We want to understand why, if I fire something at a high angle, it can go something the same distance as a far one. Many of you said that they have to be complementary. That's true, but that's really not why they do that. So the basic idea is, first you want to establish what's an equation that dictates range, right? So range is simply equal to how fast you're moving horizontally, that's important, multiplied by how much time you're in the air. So now that you've established the rule for how you gauge or calculate range, now you can look at the two situations. So if I fire something at a low angle, then we can say, well, that has a high horizontal velocity, but it has a low time in the air. You don't have to go into great detail about, the equations with that. And then you can contrast that with the high angle, which has the opposite, low horizontal velocity and high time in the air. And if you really want to tie it together, you say the combination of a high V and a low T, or a low V and a high T, can give you the same range. But I was looking for something that has touched upon those 3 points. 3 points. Okay, next one is a calculation. I made a VTAX table. I know it's kind of hard to read because I had confined space, but basically we're firing something horizontally. So there's no vertical velocity, there's no vertical acceleration, but there is a horizontal acceleration. And our height is 1.4 meters, not 140 centimeters. I mean, you got to convert to meters if you can use 9.8 meters per second squared as your acceleration. So the first thing you should have done is found the time in the air using the vertical. So I've just written the equation right here. I plugged in numbers and you get a time of 0.53 seconds. If you used 140 centimeters and you didn't convert, you would have gotten 5.3. Now taking off 1 point. I want to penalize you again for the range as long as you're consistent. So you use the Vx, multiply by that, and that's pretty straightforward, 5.3 meters. All right, horizontal velocity is if it's the ground. Well, it's always going to move forward at a constant speed, so it's going to be 10 meters per second. Vertically, you'd have to do a calculation. Okay, number 4, contrasting angles. I don't think there was any issues with that, but furthest is one closest to 45 degrees, so that's 30 degrees. Highest is the highest angle, time in the air goes with the highest angle, and then horizontal velocity goes with the most horizontal of angles. So that was pretty straightforward. Number 5 gave us a lot of you trouble. When is it not moving with zero velocity? The answer is never. It's always moving forward. So a lot of you thought the peak, it stops moving, and you were thinking vertical, but it's still moving horizontally. And it always has acceleration because it's always in free fall. Horizontally, it doesn't have acceleration, but vertically it does. So you have to be careful there. Okay, next one, 17 degrees, just 73 minus, or 90 minus 73. And then what if it's drag? So there's 3 things I'm looking for in this graph. It's lower, it's shorter, and it's asymmetric. Okay, so if you gave some indication of that, that's fine. And that's all because drag is going to slow it down as it moves forward and as well as it falls. Next, we have a vector problem where we're firing something at an angle at a velocity. Find the components. So horizontal component goes by the cosine of the angle. This goes by the sine. Some of you were in radian mode, so you got the wrong value, but I didn't penalize you after that if you were consistent. Okay, so we have the following values. You should have shown calculations. I didn't here. Now we want to use that. So the first one is how much time does it take to reach a goal this far away? Well, that's horizontal, that 18 meters. So I have the VTAX table all set up. Take a look. I'll use the components from above. Same thing with acceleration, 0 and 9.8, and we know the range. So the time, I'm going to use the x1. So I'm just going to say the time is simply going to be the horizontal information. So I use the horizontal velocity, the horizontal distance, 18 meters, and then I use the horizontal velocity to calculate above, and I get 0.88 seconds. Then to get the height, or does it go in a post, I want to find what the height is when it's at that position. You don't want to find the maximum height, or if you do, then you got to explain how that relates to the target. But the easiest thing is calculate the height. And so I'm going to use the vertical information from this table, and because I now know the time is 0.88. And so I plug in the values and make sure I put in a negative value for 9.8. I get 0.34 seconds, and yeah, that's a goal. Lastly, vectors. Okay, distance is simply the sum of these two. 15 plus 12 is 27. Some of you did displacement, which is the next problem. Displacement, as shown in this vector diagram here, is the hypotenuse, so that's pretty easy to calculate. And then to get the angle, so we want the angle from here because it's at the beginning of our resultant vector. And so we say inverse tangent of 12 over 15, which is 39 degrees. And to complete it, we want to say west of north. You could have also answered 51 degrees north of west. That's valid. Okay, and finding the difference between vectors, I know you had to go back and look at your notes, but we're going to see this again. So v minus u, you want to change into a plus v plus a negative u. So now I'm going to alter my vectors. I'm going to leave v alone, but I'm going to make negative u. So negative u is simply the same vector, but in the opposite direction. So that's now negative u. So now I'm going to add them. So I go from the beginning of 1, well, I'll go u because that's the beginning, to v, and there is my v minus u vector. Okay, what's the maximum 15 and 4 can add up to? That's easy, 19. What's the minimum? It'll be 15 minus 4, 11. Can they ever add up to 10? And the answer is no, because 10 does not fall between these two extremes. That was the point of figuring out those extremes. And then as we go from 0 degrees, right, when they're at 0 degrees, they're adding up to 19. When we put them at right angles, they're adding up to something less than 19. So this is going to decrease, right? The vector sum of these two would be this vector. If you use the Pythagorean theorem to find a value, you'll get less than 19. Hopefully this was helpful. Hopefully you learned after the fact. If you still have questions, ask.